Good morning, everyone, and thank you so much for joining us for today's webinar, Pro-Demnity Technical Requirements for Precast Concrete. My name is Claire Hepburn, and I am the Deputy Registrar at the OAA. We will begin today's webinar by acknowledging the land on which we are meeting and calling in from. For millennia, the place we call Ontario has been inhabited by Indigenous peoples and nations who have been stewards of the land and are deeply connected to its cultural and natural landscape. We'd like to invite you in a moment of reflection to acknowledge our shared responsibility to address past injustices and provide space for Indigenous knowledge and worldviews to shape the architectural landscape of Turtle Island. Before we begin, I'd like to share just some important information to make sure we all have an effective and professional webinar experience. So just know that the session is being recorded for educational and quality purposes. To maintain a stable internet connection, we have muted all participant microphones and disabled their video feeds. We highly encourage your engagement through the Q&A. I will be reminding you towards the end again. So there is a Q&A window at the bottom of your screen. If you look at the bottom of your screen, please submit any questions that you have at any point during the presentation. As they come up, they will be addressed in the designated Q&A period at the end of the presentation. So again, I will remind you, but we really encourage submitting questions through that feature. For those of you on the call today who are looking to get continuing education learning hours, please be reminded that your attendance is crucial. So we do need to see a minimum of 80% attendance on the Zoom call for you to be accredited those hours to your transcript. And just allow a few weeks for us to process and report these hours. Finally, and importantly, do note that our presenter today does not provide insurance, legal, or practice advice. And the OAA does not bear responsibility for errors or omissions in discussions during the webinar. For accessibility, we provide automated closed captioning services, and it's available in multiple languages to accommodate the needs of our audience. And finally, I am excited now to introduce our speaker for today's session. Please welcome Sarah Gray.
Thank you, Claire. Thank you to Ashley and the OAA team, and welcome to all architects and intern architects joining the session today. I am a principal and building science specialist with RDH Building Science. My office is located in downtown Toronto. We also have an office in Waterloo and Ottawa, and on the West Coast in British Columbia and across the United States. Today, I've been invited to talk about Pro-Demnity's technical requirements for precast concrete wall cladding panels, emphasis on wall panels. We're not going to be talking about precast internal structural framing systems today, so we'll focus on wall cladding panels, which is my specialty and area of focus as a building science and building envelope consultant in Ontario, particularly for the Pro-Demnity technical requirements. What is Pro-Demnity? I expect that lots of architects on this call know exactly what Pro-Demnity is, but we may have newcomers or intern architects on the call today. So just briefly, Pro-Demnity is the professional liability insurance for architects. Pro-Demnity is the name of the firm or the corporation, the insurer that provides architectural firms with their errors and omissions insurance. They protect and defend architectural practices from potential financial exposure of legal claims. So what kind of claims does Pro-Demnity manage? Well, from 2006 to 2011, which is unfortunately the most current information that I had, a big slice, that orange slice of the claims, the insurance claims that Pro-Demnity managed was related to water and water-related damage. And of that slice of water-related damage, almost 2/3 of those claims related to building envelope, building enclosure failures. And in that regard, since 2004, Pro-Demnity has excluded coverage to architecture firms for ingress of precipitation, meaning water leakage claims. However, don't freak out yet. When an architect's design meets the specific requirements called the technical requirement schedule, the architect or architecture firm will have professional liability coverage related to water leakage. So today I'm here to talk about the technical requirement schedule that Pro-Demnity has, but really I'm going to be talking about best practice building envelope design for precast wall cladding panels. So about a year ago, April 2024, Pro-Demnity issued new technical requirements, or really they were updated requirements. What do those requirements say? Well, you can go online to Pro-Demnity's website. You don't even need a login, password, or anything. You can download their technical requirement schedule. In short, they say that above grade wall assemblies that are designed and constructed according to rain screen principles that have positive drainage to the exterior will be covered by Pro-Demnity. So if your design has a rain screen wall design assembly, you meet Pro-Demnity's technical requirements, in short, right? Most wall assemblies these days do have a rain screen design, but there have been some exceptions and some nuance over time. So Pro-Demnity has 3 sets of requirements. They used to be called endorsements. One is for exterior above grade wall systems, sort of an umbrella or general term. Really, that was meant to handle exterior insulation finish systems, or EIFS. Original or older EIFS assemblies were not drained assemblies, and certainly now we do have drained EIFS assemblies. Letter B, which we are talking about today, they have a separate set of requirements, technical requirements for architectural precast concrete exterior wall assemblies. And then the third system or third set of technical requirements that Pro-Demnity publishes is for window wall systems. So again, early versions and iterations of window wall systems were not drained, and certainly newer current modern window wall systems are drained. So Pro-Demnity realizes that systems are available for above grade walls, eaves, precast concrete wall panels, and window walls that are drained. Therefore, they're telling you, advising you as architects to use and design those drained systems. So let's dig into the precast cladding requirements, which is why we're here today. So in those endorsement documents that you can download for precast cladding, the first requirement of your design that uses precast panels states that you must design, construct, test, and install those precast panels with drained and vented 2-stage joints, with insulation as part of the wall assembly, with a continuous air barrier as part of the assembly, and with vapor control or a vapor barrier as part of that assembly. Within the precast concrete wall panels, any window openings must also be drained to the exterior. So they're talking about mostly the precast concrete itself, but also the way the window is inserted and installed in that precast panel, all of which must be drained. The second major requirement for precast cladding from Pro-Demnity is that an independent building envelope consultant, or IBEC, must review and accept the design and installation of the precast cladding system. We'll talk about the requirements and qualifications of the IBEC in a bit. Spoiler alert, I would be considered an independent building envelope consultant if I am not part of the architect's original core design team. I would have to be retained separately as a third party or independent consultant. The next requirement that Pro-Demnity has for precast is that there must be a quality assurance plan in place. That quality assurance must happen both in the precaster's shop or factory And there also must be quality assurance processes in place for the on-site installation and detailing. Next up, Pro-Demnity requires full-scale mock-ups and testing of those mock-ups of a typical precast panel assembly. Once the panels are brought to site, there must be field review conducted by the independent consultant as well as yourselves as architects as part of your general review commitment. And on-site testing for water leakage must be undertaken on-site during installation. And finally, after all of the precast panels are installed, they've been reviewed, they've been tested, the independent consultant provides a 5-year or a letter documenting that there are durability and maintenance plans available for the products and that the precaster has provided a 5-year warranty on their design. So these check marks are the highlights, the summary of Pro-Demnity's requirements. Today, we're going to go into the requirements in detail. And certainly my lens is building science and building envelope design. So we're going to talk about the nitty-gritty technical details and design elements for precast cladding. So first and foremost, Pro-Demnity requires the drained and vented precast assembly. Why is that important? Well, as I mentioned, the rain screen design principle has been known and been in use for many years. I expect that many or most architecture firms use that almost exclusively as the design. And what does the rain screen design principle look like? Well, there's typically an exterior finish or cladding that's installed over insulation and over the air-water vapor barrier, which is all installed over the structure or support. So this is a very generic wall section, not necessarily precast, but this shows what we call a perfect wall assembly or a rain screen design. How is it rain screen? Well, that outer cladding is vented and drained, allowing moisture to drain out or dry out from the materials behind. That's very simple 101 of rain screen design. How could precast meet the design of a rain screen? Well, the most simple approach for providing a rain screen design for precast is using hand set precast. These are typically smaller pieces of precast. They're both smaller in sort of width and height, and also typically a bit thinner. They are acting as a cladding, very similar to how a metal panel could be formed as a rain screen cladding. An aluminum composite panel, brick veneer could be installed as composite panel. You can see that the precast is installed with an air gap between the back of the cladding and the insulation. You can see the air vapor water barrier membrane, the blue material behind the insulation, and then the concrete and concrete block backup wall behind. So classic precast assembly. However, this is not typically what folks think of when we say the term precast cladding. We're typically meaning now very large format panels that could span floor to floor or even 2 floors and are quite wide, meaning meters wide. So instead of these smaller pieces that are installed very much like natural stone, we're looking at a more prefabricated large format wall panel system. And that's the intent of today's talk. But I just wanted to mention how precast could be installed as a true or traditional rain screen assembly. So now let's look at the 2 more common precast panel types. First is what we call architectural precast or single-wythe precast. That's where we have a thicker precast panel system, maybe 4 inches deep, 6 inches deep, sometimes even 8 inches deep if it's these very large panels. Installed kind of like a curtain wall. They're hung off the edge of floor slabs with an anchorage system, and the precast spans floor to floor. Behind that, we'll have a continuous insulation layer. That's our yellow layer shown in this feature. And then we'll have probably metal studs, gypsum board, and interior finishes on the interior side of the precast system. The second common type of precast that we're seeing more and more today is the integrally insulated sandwich panel, also called a double-wythe precast panel. These panels are quite thick, 8, 10, or 12 inches thick. There's an outer layer or outer wythe of precast, very similar in looks to the single-wythe approach. But insulation and an interior backup wythe of precast panels is manufactured in the precaster's factory or shop. These panels come assembled as this sandwich to the construction site and lifted together. Once these panels are lifted together and installed, you have the outer finish, the insulation between the panel, and the interior backup or even finish fully installed. In a sense, you have a complete building envelope with a sandwich panel. So let's take a deep dive into the details of each of these types. So first, single-wythe precast. This is a very sort of crude sketch of how these work. So again, the panels extend floor to floor in height. There's insulation behind them. Between the floor slab and the back of the precast panel that's hung, we'll have to add our fire-stopping insulation and smoke seals, and then the studs and framing go inboard of that. There are cases where we have architectural precast as part of a total precast system where we have precast floor slabs and there's load-bearing precast that rest on the floor slab instead of being hung like a curtain wall. All to say, we won't go into detail for the total precast system today, but one thing to consider with a total precast system where the wall panels are supported by the floor slabs is we have those red thermal bridges at each floor slab that we'll need to mitigate so that we don't have cold spots on the floor and have energy losses. Okay, what does total precast, a building with single-wythe precast look like? Well, it looks like this. You kind of can't tell what type of precast panel this is. When I look at these photos, I can see that the panels are fairly large. That signals a precast wall assembly to me, but on the outside, it just looks like a fairly aesthetically pleasing wall. So as a building envelope consultant, I want to get into the details. How are we providing that drained two-stage joint system between individual panels to provide rain penetration control? This is exactly what Pro-Demnity is asking of architects in their design. Again, building envelope water leakage, claim number 1 in their list of claims. So let's dive in. So Pro-Demnity says that we must provide two-staged drain sealant joints. So again, those are the horizontal and vertical caulking joints between the individual panels hung off the building. This is a cut section through a two-stage drain joint. What does it mean? First, we have an outer seal. That is in fact acting as the rain screen because it has drains and vent openings typically at every floor line. That's allowing water out. It's allowing some water in to help dry any moisture that might penetrate through that caulking joint. Secondly, the second or inner seal is the air seal. So that is stopping interior conditioned air from leaking out through that sealant joint. That inner seal also serves as the final backstop water barrier or moisture control of the system. So 2 joints are required with precast concrete cladding per Pro-Demnity. If you get anything out of this session today, this is the picture that you should have burned in your mind. Pro-Demnity again says we must drain all joints, that meaning panel to panel, and also any sealant joints between windows and the panel itself. So this is a good 2-dimensional snapshot. What does it look like in 3 dimensions? It gets a little bit more complicated because we have horizontal joints and vertical joints, as I mentioned. So we've got 2 lines of sealant at the horizontal joint with a drainage space between. And we also have 2 lines of sealant at the vertical joints again, with the drainage space between. And the concept is showing moisture, water droplets draining through that airspace between the two lines of caulking to the exterior. In practical terms, what does this sort of complicated 3D drawing or sketch mean on site? Well, it's actually fairly straightforward and easy. Here's a photo of that inner air seal and final water backstop joint. In this case, the sealant has been installed from the exterior. You can see the gray caulking here. You can't see the backer rod, but the backer rod is supporting the caulking behind. You can see that that's recessed well back from the outer face of the precast finish itself. Here's another photo showing the inner seal to the left, the backer rod for the outer seal, and then the outer seal in line with that kind of reveal cant of the precast on the outer side. So 2 lines of sealant shown here in the photo. We just have a really nice cutaway to show the various dimensions. You can see to the left of the tip of the tape measure that there is a gap there. The gap does not need to be huge. I would say a minimum 3 millimeters or 1/8 of an inch does the trick. A little bit wider gives you some wiggle room and tolerance to make sure the backer rods and sealants aren't in contact with each other. So we don't need a huge airspace, but we certainly do need that space to provide the draining and venting. And just another photo of how it goes into to play on site. So the tradesperson is installing the outer line of caulking here on the horizontal. What does the weep hole or the drain slot look like? Well, this is a fairly well-detailed drain slot. It's at least 25 millimeters or 1 inch tall. It's the full width of the joint itself. You can see it has a ramped profile that's going up and inward to the air seal and backstop inside. RDH typically does not require or recommend using plastic tubes or wicks. Just leaving that joint open allows it to kind of wash itself clean of intermittent dirt or debris. And over time, we've found that the plastic weeps or wicks just fall out anyway. So detailing a nice, healthy drain slot meets the intent of Pro-Demnity. So we often get the question, do we really need the weeps? Well, Pro-Demnity says we do, but just to bring the point home, we were conducting an investigation of some water leaks on an improperly detailed assembly. And we cut open some caulking joints and found that there was water trapped within the sealant assembly. So yes, in fact, weeps are needed to allow any water through flaws or little skips to drain out. Again, we're mitigating the issue of water leakage that has been sort of the sore point for Pro-Demnity over the years. So that's the 2-stage drain and rain penetration control function. Let's now look at how precast panels are insulated and how we provide the air barrier. Here is a detailed sketch drawing of a precast assembly. This is at a floor line, any generic floor line. You can see that this, again, is a single-wythe architectural precast. It's hung with large anchors that are set within and embedded within the floor slabs. The first thing we want to look at is to understand that the precast concrete plus the sealant joints, again, form that air and water control function of the building envelope. Here in the red dashed vertical line, I'm illustrating the air seal and that water backstop, and you can see how that is ramped at the floor line or at the panel joint to drain water out. On the inboard side of the precast, we have the air impermeable, typically spray foam insulation installed directly against the back of the precast. We have the smoke seals and fire stopping insulation between the precast and the floor slab, again, code required, but also providing an insulation and air control function shown here. So once precast is installed on site, it looks like this. There's lots of concrete here, not the prettiest of picture, but this is where we can begin to assess in the field the detailing of the seals, the insulation, etc. You can see here that the precast panels are also part of a total precast system. There's those large steel anchor plates tying the wall panels back to shear walls and other assemblies. There are holes that were used to lift the panels into site using a crane or tower crane. So all of these joints and bolt holes and tie and lift penetration holes need to be sealed, else we'll have air leakage problems. Back in the old days, as I like to call it, let's say the 1980s and 1990s, we typically did not use spray foams. We've come a long way in the spray foam industry these days. But back in the day, we used metal studs and fiberglass batt insulation. The problem with that is that we didn't get a tight air seal to the backside of the precast. That allowed convective air looping, which deposited warm air and condensation on the back of the panels, which would then form ice. So this is an example of what not to do. We don't do this anymore. We do not want ice on the back of the panels because when ice melts, it forms water, which is a form of water leakage. Again, going back to first principles for the Pro-Demnity requirements. So going back to that precast building we showed, we want to seal all the joints in the precast, both from the interior and the exterior. We also want to seal all of those anchor plates because those can form or allow air leakage between the plate, the concrete, and through the bolt holes. So just a close-up of what you'd want to look for on site. So we have not yet installed the insulation. So we typically aren't on site when the insulation is being installed. It's a safety PPE issue, but I just want to illustrate the insulation here. This is the bright yellow layer is our continuous insulation going from our foundation wall up and behind the precast cladding. We've provided a blob of spray foam here in this detail around the steel anchor plate, again, to provide insulation and air sealing. Moving up, very similar to the sketch I showed earlier, here at the floor slab, we're providing insulation between the precast and the floor slab, up the wall, and providing insulation around the precast anchor. This is a best practice detail, part of the Canadian Precast Institute design guide, which I'll talk about in a bit. So these are illustrations for single-wythe or architectural precast. What about double-wythe sandwich panels? Well, here's an illustration of a precast panel going up in Waterloo. From the outside, one couldn't tell if that's single-wythe or double-wythe, but when you see the thickness of the panel and you see that turquoise blue foam, that's the sure sign that we have a sandwich panel being installed at this building. Here's the schematic concept of the sandwich panel. Again, these are hung like a curtain wall off the floor slabs, but when they're hung, it's an all-in-one building envelope assembly. We still have to install our fire stopping and smoke seals at the floor lines, but we don't need to provide insulation around the precast anchors because our air, water, and insulation layer is within the panel itself. How do we detail sandwich panels for rain control? The exact same way we do for single-wythe. We must have two-stage drain joints at all panel-to-panel joints. We need to have that nice, healthy rain screen slot as well. What does that really look like for a sandwich panel? Well, here on the exterior, this is where we provide the double line of sealant. There's also an option and a strong recommendation to provide some insulation continuity at the joints there in the middle. And we often see and recommend an interior line of sealant that can serve as a finish if that interior face of precast is in fact going to be the exposed finish without drywall in the building. That interior seal also provides a second air seal so that we don't get air leaking into that inner joint and perhaps causing some problems. So often the best practice is a triple seal approach for deep sandwich panels. What about insulation and air control for sandwich panels? Well, we already talked about that. It's an all-in-one solution. We have the insulation between the two wythes of precast, and we have that inner line of air seal as well. So sandwich panel, single-wythe, slight differences in detailing, but we still need the rain control, continuous insulation, and the air seal. Let's look at window detailing because after you install the caulking in the panels, half the battle is over, but the next battle is to get those windows airtight and watertight as well. From my practice, looking at older buildings that have aged 10 or more years, we often find that eventually the glass and frame joints and the frame to precast joints will eventually leak. Sealant does deteriorate. There are issues, so we want to anticipate leakage and provide drainage out of the system. Certainly out of the precast, our two-stage drain approach is providing the drainage, but at windows, we need to provide a subsill membrane flashings to collect any water leakage from the window and drain it outward. In section on a precast single-wythe panel, it looked like this. We typically install a back-dam angle, which can support an upturned leg of flashing, forming a bathtub. That's the subsill bathtub flashing. We'll have an air seal. That's the green line between the window frame and the subsill membrane. That forms the air seal, all of which will be drained. We also recommend a metal flashing with a drip edge to keep water off the top of the precast and reduce the amount of exposure of sealant joints to rainwater. Factory insulation is a great idea if that can be accommodated because the windows can be installed in a climate-controlled, dry condition. It's very comfortable. Folks are walking on the floor, installing from the floor instead of at height, 20, 30, 50 stories up in the air. So we do see more pre-panelization of both the precast and the windows in the factory. Here's a photo of that subsill membrane flashing. In this case, we're not carrying the membrane all the way across to the outer face of the precast. We're recessing the membrane to cover the critical joints and form that bathtub with the upturned leg at the back of the sill and also at the jambs. Here's what that will look like in a little bit different configuration. This is a different building, but again, you can see that subsill flashing. You see the window on the interior waiting to be installed. So the critical detail for windows is that subsill membrane flashing and drained sealant between the window and the precast itself. Talking about some other best practice details for precast. This is not necessarily required by Pro-Demnity, but we feel it will make your building look and perform better. My first question is, do metal drip edges at the top of a precast or concrete wall make a difference? And as shown on this slide, yes, they do. So you can see for whatever reason, the metal flashing at the top of this wall stopped at this sort of extended balcony leg, and where there was no flashing or drip edge, the concrete has become significantly stained and frankly, in my view, unsightly. You can also see that below the window here in the middle of the photo, there's no metal sill flashing or effective drip edge, at least, and you can see the dirt and water staining below the windowsill. So metal flashings, though they do cost money and maybe they don't give the specific aesthetic that some folks like, can make a difference in aesthetics and performance in the long run. That's why we recommend them. Another common best practice consideration is to use a metal cap over all sky-facing joints, not just to shed water and control staining, but also to mitigate water leakage through sealant joints that will eventually crack and debond. So we don't want to see this. I'd like to see a metal cap flashing over this exposed panel top edge. Okay, so we've talked about drained and vented two-stage joints. We've talked about installing insulation. We've talked about the air barrier and air seals, and vapor control is the precast itself. What's the next requirement from Pro-Demnity for precast? That's the review by the independent building envelope consultant to conduct a peer review of the architect's design of the system to make sure it meets Pro-Demnity's requirements. So who can be the IBECT? A licensed architect who's not the design architect on the project could be the IBEC. Also an engineer, typically a building envelope engineer, could serve that role. Certainly you want to hire an IBEC who has experience with precast, both design and installation on site. The IBEC cannot be the same person or company that's providing Terrion's Condo Bulletin 19 services. They want to maintain separation in that regard. And as I mentioned before, the IBEC needs to be independent from the primary design team. The IBEC is a third party. Typically, we see developers retaining the IBEC. That'll be a discussion between you, the architect, and your client, the building owner or developer, on who needs to retain the IBEC. Pro-Demnity doesn't get involved with that bit, the sort of businessy bit. Pro-Demnity just says there must be an IBEC on the project with precast. So the IBEC first reviews the design, all of those elements that we talked about through the sketches and photographs. So we're looking at precast cladding components. We're looking at all the building envelope control layers for water, thermal, air, and vapor. We're looking at the precast anchorage, not so much the structural design for building envelope, but how we're detailing around those anchors with sealants, caulkings, and the spray foam that I mentioned before. The IBEC reviews the design of transitions at penetrations like windows and ducts. And they're making sure that the precaster and the contractor on site have quality assurance and testing procedures in place. So once the IBEC reviews the design, probably provides some written comments or sketch comments, you, the architect, must incorporate those recommendations related to the design, testing of and installation of the precast into your final or issued for construction design. What types of detailed services does the IBEC provide? Well, there's a set menu of base services that are required for the IBEC to provide to fulfill the Pro-Demnity requirements. And there's certainly some value add considerations that the architect or the owner developer might consider as well. So there's the list of base services and then a couple of value add considerations. And I'm going to go into these in more detail. Before any precast gets manufactured in the shop or brought to site, the IBEC conducts a document review related to the precast. We're looking for the Canadian Precasters Quality Assurance Certificate, making sure they have an in-shop quality assurance, quality control procedure in place. We're looking at their maintenance manuals, and we're making sure that they can eventually provide a warranty. What does their standard warranty say? Does that provide adequate coverage for the project? As I mentioned, the next step after the document review is that design review. So as part of that, the IBEC is making sure that the architect's design follows best practice design guides. Those include, again, CPCI, Canadian Precast Concrete Institute's Architectural Precast Concrete Wall Guide from 2017, and CSA standard A440.6 for high exposure fenestration installation. So both of these guides basically include all of that best practice detailing that I showed in my previous slide, things like providing critical barrier continuity, seals, air barrier continuity, insulation continuity. The CPCI guide is available as a free download from their site. Malcolm Hatchborn and others authored this guide. It has good narrative discussion, but it also has a series of details. This probably looks familiar. I just showed that earlier. That shows not only the installation and concepts and geometry for the precast in comparison to the structure and floor slab, it also shows those building envelope control layers which need to be continuous throughout the design. So CPCI's design guide sketches are very, very helpful. And CSA A440.6, in high-level summary, that basically says provide subsil membrane flashings and drain sealants. Of course, there's more detail in that standard, but again, they're looking for best practice window installations. Okay, we've got the design over with. The precast cladding manufacturer is on board. They're producing their own shop drawings. The IBEC needs to review the precast shop drawings as well as the architect, of course. On the engineered shop drawings, we're looking that those drawings are project specific. They certainly need to include the structural attachment of how the precast is going to get hung to the building. And we're also looking for the continuity of the air seals, the insulation, the drained rain screen design. We're looking for those tie-in details, as I mentioned, and there are typically little details that the precast shop drawings may miss, such as sealing around light fixtures, hose bibs, scuppers, etc. So we want to make sure that those typical details are also included on the shop drawings. The next step in the IBEC process could be for the IBEC to conduct in-plant or in-factory reviews during the construction and manufacture of the precast panels. That's not required by Pro-Demnity. That may be something desired by the project team if there are tricky details or some sort of aesthetic that needs to be reviewed in the plant. But certainly the next mandatory step for the IBEC is to review full-scale mock-up testing that typically does occur in the precast factory. So we want to make sure that that happens. This is what that could look like. Here's the precast. The precast itself, we're looking for any cracks or manufacturing flaws, but that kind of review can be pretty boring. So we're really looking to have that window installed as part of the mock-up in the factory. Even if the windows aren't going to come to the site with the windows, we want to conduct a mock-up in the shop that does include a window. Tests are conducted then on the shop where we're actually really testing that two-stage drainage joint, and we're testing the installation of the window within the panel itself. So if we've passed the mock-up, the next step is for the factory to make all the precast panels and bring them to site, and then the IBEC needs to conduct field review. Pro-Demnity does not prescribe a number of site reviews. RDH's typical approach is to provide one review or one site review per floor of panel that's being installed. And certainly we could conduct additional or more than one review per floor if desired, or if there's, again, some tricky details. What does our field review include? Hands-on, detailed review, not just a drive-by in the car, not just a checkbox to say that we were on site when we maybe weren't on site. Our RDH team is going on the wall, hands-on, either from exterior scaffolding or from interior access to review the two-stage joint seals, conduct adhesion testing of the sealant joints, look at any non-standard details that may need some RFI and site instruction, and talking to the contractor installer to make sure they understand all the details that need to happen so that Pro-Demnity is satisfied. What are we looking for the sealant joints? We're making sure that the specified material is being used. We're looking for backer rod, surface prep. Some sealants require primer when applied to precast, so we're checking that that's being applied where required, and we're spot checking the profile. Here you can see a sealant joint that's just way too thick. Having an inch or more depth of sealant is certainly a waste of material. And that blob of sealant is not going to provide the sort of stretch or squishiness that's needed to accommodate thermal movements or structural deflections. So when we see sealants that are too thick, we'll flag those for replacement. On the opposite side, we also see in some cases where sealant's been applied too thinly. It just doesn't have enough bite to the precast to form an effective seal. And in some cases, even if the sealant is just the right thickness, it can be debonded. That may be because of the surface texture of the precast. Maybe there was some dirt, dust, debris on the concrete when the sealant was applied, or some other reason. So we'll do probing and test cuts in the pull test to confirm that sealant's adhered, and where it's debonded, we'll mark those areas for replacement. From the inside, we're looking at those interior air seals. Here you can see that lateral restraint anchor. There's black sealant around part of that anchor, but the contractor missed the sealant on all four sides. So we'll have them seal that all the way around. A second example here on the right-hand side, the yellow arrow showing a nice complete seal system, but the left side anchor, for whatever reason, they forgot to seal that anchor. So we'll flag that so that we get those sealants installed to reduce air leakage. And bigger penetrations like this exhaust duct bank, it looks like this installer used a membrane product to more effectively seal the exhaust box to the back of the precast. Again, these seals need to be installed before the spray foam insulation is applied. Spray foam is insulation. It's not an air seal in this case. So we want to see caulking and membrane products to provide the air seal. So once it's installed, we're going to be starting our field testing required. What kind of field testing do we do? Well, one of our favorite tests is to make sure those two-stage joints are in fact draining. So we use sort of a veterinary hypodermic needle rigged up to a gravity-fed water line. And we're just injecting water into that airspace between the inner and outer seal and seeing if that water drains out the bottom weak pole. It's a very simple, easy test, no ASTM standard on this one. We're just checking that the seals are continuous and that they're draining. We'll certainly conduct more standardized testing, the ASTM E1105 field water test. Here we're testing the window installation in the precast where we have the panel-to-panel joints. We'll also test those. On the inside of this building, we'll have a polyethylene chamber constructed, and we're drawing a pressure difference across the window and panel to simulate a wind-driven rain. So once we pass the field reviews and the on-site test and the installation is as designed and as per best practice, the IBEC will provide their finer letter to Pro-Demnity. There's no format for that. It's a one-pager that attests that the IBEC has fulfilled all of the steps that Pro-Demnity's technical requirements lay out. So that was a lot to handle. I'll do a quick summary and then we'll take some questions. Pro-Demnity's requirements for precast cladding. First, remember to always use best practice enclosure control layers for your precast cladding assembly. We certainly want to use two-stage joints. That's the big message here today. You'll need to retain an independent building envelope consultant to fulfill Pro-Demnity. That person or firm will do a shop drawing review to identify and resolve the real details for the building. Establishing good QA/QC procedures during fabrication and installation, that is including the implant mock-up, review, and water tests. Then, once the panels are on site, conducting field review and more testing. And that's that. So if you have questions or want to explore more, you can visit RDH's website on our technical library. You can search the word precast, and we have 3 guides, including CPCI's best practice guides and some other white papers and peer-reviewed papers regarding precast cladding design. And with that, we'll hand it over to questions.
Thank you so much, Sarah. I just am going to encourage those on the call today to put your questions in the Q&A. So just click on the Q&A and please type in your questions for Sarah. I think Ashley has a couple of questions to start us off with, and then, oh, I see one coming through, and then we'll shift back to your questions.
You want me to go ahead?
Yeah, just go ahead with the first.
Okay.
Okay.
First question for Sarah. What is the most common issue or failure that you see on site with precast cladding?
Water leakage, which is why we're here today and why Pro-Demnity has provided these technical requirements that must be followed for them to provide coverage on any claims that related to water leakage. So what types of water leaks do we see? incomplete two-stage joints. Maybe the interior air seal has a skip or a miss, or it's debonded or has other problems, allowing water to come all the way into the building. That's the most common that we see, certainly. Other pieces can be the leakage around the window. Again, if that subsill flashing and sealant system isn't completely detailed, maybe there's a gap or a miss in the membrane itself. Even though we have membrane, maybe there's a pinhole leak through there. So water leakage is the most common problem.
Okay, great. We have a question from Priscilla. She's asking, are precast wall assemblies required to have a third-party building envelope specialist review? Or do any other wall systems also have this requirement?
Yes, so there are other wall systems that have that requirement, particularly these sort of pseudo-drain, pseudo-undrained systems. So precast itself is not a drain system, but detailing the two-stage sealant joints with drainage makes the system drained. The other system I mentioned is window wall. So many of our condos today have sort of the floor to ceiling window wall system. Originally, those did not have drainage planes and were the result of many leaks and claims that Pro-Demnity saw. As I mentioned, today's rain screen designs are available for window wall systems, but Pro-Demnity still requires an IBEC review of window wall. So certainly precast cladding, window wall requires the IBEC review. Any other sort of pseudo drained or undrained systems I mentioned, EIFS, may require IBEC review. So I would urge an architect or a firm to contact Pro-Demnity, discuss the wall cladding assemblies that you're considering to confirm if they fall under Pro-Demnity's requirements for this IBEC review. But certainly precast cladding that we showed, single-wythe and sandwich panels do require it, also window wall.
Okay, that's really good, clear information. We have a couple of people who also just wanted to know if we're getting copies of the presentation, which we'll send out after. And I can imagine why, because your slides are so detailed, and I feel like people will be wanting to refer to those going forward. So yes, rest assured, we'll send that out after the presentation. Another question from Priscilla, and hopefully you haven't already answered this, but she's asking, are only precast wall assemblies required to have a third-party building envelope specialist review? I think that might be the same question.
I think that's the same question. Yeah. So again, yes, precast, yes, also window wall, and possibly other systems as well.
I'll move on to the next question. Sorry about that. From John. John wants to know, in a double-wythe, I hope I've said that correctly, double-wythe precast wall assembly, the schematic detail indicated the backer rod and sealant tight to the back of the integral insulation.
Mm-hmm.
Must this be in this position, or can it be further back, closer to the inferior face of the precast wall panel?
There is not a must, but I will say that it becomes very difficult to install the inner sealant joint from the outside with that ramped drainage plane profile when it's so far back. So if I have a sandwich panel that's 8 or 10 inches thick, and I have a tradesperson on the outside that needs to put a caulking gun all the way through that 8 or 10 inches to detail that sealant joint, it gets very difficult. Not impossible. There are tools and extensions for caulking guns to get into tight, deep spaces. We typically prefer, and the CPCI guide shows that line of sealant aligned with the insulation, really on the back side of the outer layer of concrete, to provide the air seal and water seal with the drained profile further towards the outside. It's easier to construct and detail properly. That also puts the perfect rain screen approach that I showed at the very top of the presentation sort of more in line with the preferred practice. So yeah, it's not a hard and fast rule, but there's some things to think about in terms of practical installation on site and getting that desired air tightness and water tightness in a good detail.
Good. Okay. So I think John's clarifying, the question was more related to the interior line of sealant on the warm side of the insulation, but thank you for clarifying.
Okay, yeah, so that would be when we have that third line of sealant. So on the outside, we'll have our two-staged drain required line of sealant.
Okay.
The third or innermost line of sealant is not required, but for the reasons I discussed, aesthetics, reduction of gunk building up in the joints, etc., we've seen some projects include that inner third line of sealant.
Okay, then hopefully, John, that makes everything clear for you. I think actually you have one more question. We still have a little bit of time. So again, if there are more questions coming in, please.
Yes.
Please
Okay, second question. In what situations or building types would you use single-wythe precast versus precast sandwich panels?
Sure. So this is a conversation for the design team, the owner team, and the construction team. Certainly, it's an early design decision. So it depends on whether or not the constructor, builder, or CM is on board during the design stage or not. Single-wythe precast is lighter in weight. Again, I mentioned it's a 4 or 6 inch thick panel. It's still heavy, but it's lighter than a very thick 8, 10, 12 inch deep sandwich panel. So there are logistics to think about. When you hang the precast off the structure, that dead load must be accommodated by the structure. So a thinner panel could mean lighter anchor, lighter floor slab. Thicker, heavier panel means stronger, thicker, reinforced floor slab. The style or the means by which the panels are erected, installed on site. Again, a lighter panel may take a lighter crane or a different type of equipment. You're certainly going to be using a heavier duty crane to lift those big sandwich panels that I showed at the Waterloo Courthouse. So some site logistics, etc. Now, the sandwich panel, as I mentioned, gives you outer cladding, insulation, and potentially an interior finish all in one. So once that panel is installed, you get most of your building envelope complete. That means you're getting done faster. You still have to go back and site install the sealant and caulking joints, but you're in a nearly watertight condition and in a warmer condition, particularly for constructing over winter with the sandwich panel. So a couple of considerations, pros and cons for both types of systems.
Okay, great. I'm not seeing any more questions coming in. I feel like there was a very precise and thorough presentation.
Thank you.
And so I think we can probably wrap it up unless there's any other final parting thoughts, Sarah, that you thought were helpful to mention.
No, well, thank you all for attending. Certainly check out the CPCI design guide, the CSA standard as well. Some resources available on the web and on RDH's website. And certainly if there are any other questions, you're welcome to follow up with me for any project specific questions. So thank you to everyone today.
Okay, great. So just a couple of closing announcements. As people are keen to see the presentation, we will be sending out the slides, and we will also be sending out a survey. I know some people have already commented that they found this session really enjoyable, but of course we welcome any other feedback. As mentioned, we will be uploading hours. So if you've attended 80% of the webinar, you will be getting learning hours for this session. And then next week, we have another great webinar coming up on designing spaces for childcare. And I think that one's also climate action hours. So Again, a good way if you need to get your climate action hours, please do think about enrolling. Otherwise, thank you so much, Sarah. That was a really informative, very, very helpful, precise presentation. And I think our listeners will get a lot out of your content. And the delivery was also very, very clear.
Thank you.
So thank you so much and have a wonderful rest of your day, everybody. Enjoy this warmer weather. All right, take care.